Okay, so this is Math Excel homework number 21, and this is problem number 4. It says, suppose the lengths of the pregnancies of a certain animal are approximately normally distributed with mean 216 and standard deviation 20. All right, so what is the probability that a randomly selected pregnancy test lasts less than 208 days? We're finding the probability that x is less than 208. So we're going to our calculator and we have our population mean and our population standard deviation. So this is the easiest kind of problem to work, where we're just going to enter in, because we know this is less than 208, so that would be like over here, less than 208, so everything up to 208 from the left, from negative infinity to 208, would be negative 1 times 10 to the 99th power, and then we would do 208 as our upper limit, so this is our lower limit and our upper limit, and then we do our mean, which in this case our population mean was given to us to be 216, and our standard deviation was 20 days. So we put all of that in our calculator and it comes out to be 0.344578. So to the nearest 4 decimal places, that's 0.3446. So we'll put that here. And then the next thing it asks is to interpret that probability. And so we know we would go to the nearest hundredth place, 0.34 would be what that would be rounded to. So that'd be 34 out of 100, right? So that would be 30. Oh, hold on, let me look at the sentences. We would expect pregnancy to last more than, no. So this is more than, this one's exactly, this one is less than, which was what we were looking for. So actually we're going to go for C down here, where 34 is less than. Okay, so here on part B, it says, suppose a random sample of 17 pregnancies is obtained. Describe the sampling distribution. So that is a big deal because that's where we have to invoke these guys, these adjusted means and standard deviations for the sample, because it's a sampling distribution, that's how we know. And so describe, a lot of times with describe, they basically mean, is it normal, is it not normal, is it skewed? And then they also mean where is the mean and how far is the spread, what's the standard deviation. And so by center, they mean what's the mean, and when they say what's the spread, they mean what's the standard deviation. All right, so here, the sampling distribution, normally our rules for a sampling distribution to be normal. Normally, we can use the central limit as long as our sample is greater than 30. In this case, our sample is actually 17, which we know is not greater than 30, but we're kind of, we get a pass. We get to say it is still normal. And the reason for that is because this sample came from a population that we knew that was normal. And so we get a pass on that one. We don't have to follow the rule on this one. All right, so our mean of our sample will be the same as the mean of our population. And then our standard deviation, or sigma, will be 20, because that was the population standard deviation divided by the square root of our sample n, which was 17. And that comes out to 4.8507 to 4 decimal places. All right, so in part C, what is the probability that a random sample of 17 pregnancies has a mean gestation period of 208 days or less? So the probability that X is less than or equal to 208. So, and we're still dealing with our sample. So because we're still dealing with our sampling distribution, we still have to use our mean of 216, the population mean, and we're still using sigma of x subscript x bar, which we got to be 4.8507. And so we're going to do normal CDF, and we are looking for less than or equal to 208. And so we know on a number line that would look like this. Here's 208, and we would be doing everything less than or equal to that. So basically we're doing negative infinity up to 208. So our lower limit will be negative 1 times 10 to the 99, comma 208. Our mean will be 216, and our standard deviation is the 4.8. I'm running out of room. 4.8507. All right, so let's put that in our calculator. Okay, and so to the nearest 4 decimal places, we get 0.0495, and then it goes 48, but they only needed 4 decimal places. Then interpret this probability. We are going less than, so which one of these? This is exactly 208. This is 208 days or less for B, and this is 208 days or more. So we know it's B because that's the one that's less than 208. And so we would expect out of 100, out of 100 independent random samples, we would round this sucker to the nearest hundredth place, which in this case, to the nearest hundredth, we're talking about 0.05, which would be 5 out of 100. So this would be a 5 here. Okay, so on part D, what is the probability that a random sample of 30 pregnancies has a mean gestation period of 208 days or less? So, I mean, if you're like me, you're like, well, what did they change? It's still 208 days or less. Why isn't it the same answer as last time? Well, what they changed on us is in the sample size. And because we're still doing sampling distribution, you're going to have to adjust. Your mean stays the same. It's going to be this guy right here, your sigma, your standard deviation that changes. And the reason why it changes is because your n changed. Your n became 30 instead of 17. So I went ahead and calculated this for the sake of time. And 20, our population standard deviation from the original problem, divided by the square root of 30, our n here is 3.65148. So we're now going to put this in our calculator and do our normal CDF, right? And our lower limit still negative 1 times 10 to the 99th power. Our upper limit is 208. Our mean is 216. And our standard deviation is going to be the 3.65148. And that may be a little bit extra there on the decimals. And so I'm getting 0.014227. I'm guessing they only want 4 decimal places. So 1, 2, 3, 4. So 0.0142 is all they need. And interpret that one. We're still less than 208 days. So this is 208 days or less for A. 208 days or more for B, so it's not that one. And C, exactly 208, so it's not that one. And so we know it's A, and out of 100, you're going to take this sucker to the nearest 100th place, so we would expect 1. So in part E, they're asking us to conclude whether the result is unusual or if it is expected. And our result, as you remember, is 1 out of 100. In other words, that's 1% of the time. And that's definitely less than 5%, which is kind of our rule of thumb for things to be unusual. Anything less than 5% is unusual. So this is unusual. And so if I have a bunch of these X bars, a bunch of these samples, right, sampling distributions, we would expect their mean is in one of these way out here in the tails. If they're getting a mean that was, what was the mean? Well, 208 or less, basically. And so if they're getting a mean of 208 or less, that's way out there in the tail. So it is less than what we would expect for the mean. All right, and then in part F, what is the probability a sampling size of 20 will have a mean gestation period within 8 days of the mean? So, okay, so in part F, the probability, again, we've changed our sampling size to 20. So that means our mean is going to stay the same, but our standard deviation is going to change again because we've changed our sample size again. So that 20 on top stays the same, but that square root 20, this time coming from here, I went ahead and calculated that out to be 4.4721. So we'll need that. And then if we're talking about is within 8 days of the mean, then we're talking about going 8 to the left and 8 to the right in either direction, so between 208 and 224. So we're doing normal CDF, we're doing 208, comma, 224. Our mean now, no, I mean our mean hasn't changed, it's still 216, but our standard deviation now is 4.4721. And I put that in my calculator, and that comes out to 4 decimal places, 9.92636, so 0.4, so 0.9264. All right, and that is problem number 4.